Lab number 3, study of the principle of operation of residual current device. Graph is presented on the slide number 8. Please check it now before we start our lab work. Let's connect the circuit. We take the cable and we connect L1 to the module TTIT. I hope you all remember what TTIT stands for. Then the second cable goes to the neutral of the module. From the top to the bottom where the neutral is. The third cable is connected from L1 to the RCD. RCD is residual current device. On the rightmost block, here on the leftmost block of the board. The next cable is connected. So while we take the next cable, it's connected from RCD to neutral. Yeah, we start from the TTIT and go to the RCD. We take the black cable and connect the RCD to the bottom neutral. We take the red cable and connect the RCD to the second part of the module. We need to remove all the cables as they're not relevant to the current lab, and they will not show the RCD working principle, and that's why we need to disconnect all of them. So all we leave is all the cables coming out of RCD, and we connect the appropriate cables to the module on the top. Connect them with RCD. Now we connect the human from L1 to PA as shown in the lab details. The second part is coming out of the amp meter to the hand of the human. So we have the appropriate resistances, which are resistances of the ground and the shoes. Now we need to check if the circuit is working and properly connected. We turn on the RCD. RCD in Russian is УЗО, устройство защитного отключателя. So now we turn on all the RCDs. RCD block, we turn on the power supply. Then we need to check the correctness of the circuit. We need to see how much the current rise will be. So we see that the current rise is only a very small amount. So we increase the resistances of the ground as we go in the lab. So we need to connect the module to the ground. As we see, we didn't connect the module to the ground. As we increase the resistance of the ground. Now we need to connect R1 as shown in the circuit diagram. So we connect. We increase the resistance. We decrease the resistance as it was increased before. So, and we see the current value that's shown in the amp meter. So we're not connected to R1 yet. So that's what we're gonna do. We're gonna connect the TTIT section to R1. Please check the details in the circuit shown. And we will see the changes in the amp meter after we turn it on. So we check the correctness of the circuit. So now we see the rise in current. It's about 13 amps. Now what we do is we connect S1 and S2, so we remove the resistances. We turn off the circuit first because by electric safety we cannot work with turned on board. We first record all the measurings, which is 13 amps. So we connect the S1 and S2. If we connect S1 and S2 means we were removing the resistances. In Russian it would be the перемычки. So by connecting S1 and S2 we are removing the resistances, allowing the current go directly through the person. That way we're gonna see how the current acts. We should see a very high value of current. So as we can see, the current value jumped very high, and it's about 100 milliamps. This is very deadly for a human being. So we record the number. Now we shall see the isolation of the electric device. We connect S4 and S3 as shown on the circuit diagram. Please check it. So we take another 2 cables and we make sure that we connect S4 and S3. So it's right where the R1 and R2 are. What it means is that we're creating extra resistance. Take the second cable and we're connecting another resistance. So we're basically creating extra resistance. As we see, the value didn't change, so S2 and S4 and S3 didn't really do anything to the human being apart from killing it twice. So we turn it off. Now we remove the cables and create the resistance between the human and the ground. Now we removed all the перемычки. We removed all the resistances basically. And we're gonna see that as we leave S4 and S3, our current value will be very, very small. So we connect the RCD board so we see that the current value is very tiny. Make sure that the resistances are also small. And we record the values. So we record the values as we did before. We remember that when we had S1, S2, and S3, S4 connected, we had the value at 300, resistance as 0.05 milliamps. We had it at 1, resistance 1, we had it 13 milliamps. We had 4 milliamps when we had 40, the value of resistance. Now we record everything. We increase even further, and we will get 3 milliamps at 300. We will get 2 milliamps at 500. And that will be our least number. As we increase even further, it will remain as 2 milliamps. So what we're going to do next is the last part, is we turn on the list resistance and turn on the RCD. And what we're going to get is we should get the same value as before, 13 milliamps. So we turn the resistance back on as it was before. The RCD is on. And we turn on the circuit. The value is back to 13 milliamps. So that's the initial value we had earlier. Thank you for your attention and have a good day.